Hello, in this lesson, topic 4.7, we're going to explore angles. Angles are everywhere in our life. Railroad crossings, when we cut up pizza or cake, intersections and parking lots. We see angles everywhere. And in this lesson, we're going to identify different types of angles and angles that work together and angles that are opposite angles. So we'll look at all different kinds of angles in this lesson. In lesson 4.6, we learned about different types of geometric terms, such as line, segment, ray. When we take two rays and put them together, as in this picture here, what we form is an angle. So angles can be oriented in any way, but angles always have a point at which two parts meet. And that point or end point is called the vertex. So what we have here is we have an angle that we can identify as LMN, or we can read it the other direction, NML. So we can identify this angle two ways, but what's important to know is that the vertex, that point M, that's always going to be in the middle, no matter what. So when we name an angle, we name from the outside to the vertex and then to the other side. So we can look at this angle as LMN, or we can look at it the other way as NML. And both of those are perfect. One is not better than the other. And we use this little angle symbol before we identify the points. So you can use that angle symbol when you're writing angles. Protractor use is something that's really great, but in this course, because we are online and even our book is not to scale, we don't actually use a protractor to measure angles, so you do not have to purchase a protractor. But it's good to know how to use one. If you've got an angle that you want to measure with a protractor, you're going to place one part of the angle on that straight line at the bottom. So this point BA, we're placing on the line. And then we're always using 90 degrees as our reference. So 90 is the straight up and down there. So we can see that this angle is more shallow than 90 degrees. And that helps us to read because we have two large numbers, between 100 and 110 degrees. And then we have two smaller numbers between 80 and 70 degrees. And that's the one that we want to use to read this angle because we know that this angle is not at 90 degrees. So this angle is at 75 degrees. It's halfway between 70 and 80. So we can name this angle, angle ABC, or we can name it angle CBA. And that angle is 75 degrees. Angles are classified according to their degrees. So if we look at intersecting lines and whether they intersect at 90 degrees, whether they're perpendicular or not, doesn't matter. If we look at all the angles that are formed there, they are going to equal a full circle, which is 360 degrees. So these angles are classified based on how many degrees they are, and we start with their small angles, which are called acute angles. And I always remember that as being small because of the word cute in acute. So these are angles that are less than 90 degrees. Remember that 90 degrees is that kind of perfect perpendicular, the two lines to each other. So we can see that this angle is far smaller than that. So therefore, that's an acute angle. Right angles are exactly at 90. So we have to be shown this square box in the corner. We have to see that to know that that's a right angle. We can't make assumptions. If we don't see that box there, it means it's not at 90, even if it looks like it. It should always be present there. Obtuse angles are angles that are greater than 90 degrees, but less than 180 degrees. So if we use that 90 as kind of our reference point, we can see that this angle extends beyond the 90. It's going further. So that would be 90, the part that I'm shading, and then a little bit more. So I would approximate this as 110, 120 degrees, but that would be approximately. 180 degrees is straight. So straight line is 180 degrees. So that obtuse angle up above, if we drew a straight line there, then we would have to have a bit more to make 180 degrees. So obtuse is not at the straight angle, but is greater than 90 degrees. Straight angles go right on a line. That's really critical for us to know that every line that we have forms a 180 degree angle. And then the last kind of angles we have are reflex angles. These are angles that are bigger than 180 degrees, but smaller than a full circle. So we can see this one is definitely going to 180 there. So that would be like where the straight line is. So that's 180. And then on the bottom, it's going almost another 180, but not quite. So that's an outside angle, a reflex angle. So that would be a very big angle. Maybe I would approximate that at about 350 degrees, something like that. Now let's take a look at pairs of angles. The first kind of pair is called complementary pairs. So complementary angles can be remembered through the first letter, C, which you can think of as making a corner, which is a memory tool for remembering that these two angles are going to equal 90 degrees. So complementary angles equal 90 degrees, and they can be adjacent, which means touching, or they can be separate from one another. So let's look at two adjacent angles, angles that are side by side touching each other. So angle ADB that I'm marking in dark blue, that angle ADB or BDA is 58 degrees. And then the angle that is beside it, angle BDC, I'm marking in light blue, or you can name it as CDB. That angle is 32 degrees. So those two angles added to one another make 90 degrees. And so these are complements. They are complementary angles. So those are adjacent angles. So I'll just write that word down. So those are adjacent, which means next door or touching each other. They don't have to be adjacent angles. So in the second example here, we have angle PQR. Whoa, having trouble. PQR or RQP. Remember that the vertex is Q, so that's going to be naming in the middle. And that's 21 degrees. And then if you're given another angle, angle UTS, or we can name it as STU, that angle is 69 degrees. And again, 21 plus 69 equals 90 degrees. So these two angles are complements. They're complementary angles. Supplementary angles are two angles that add up to 180 degrees. So we can remember supplementary by the letter S. We can think of the word straight. Straight angles are 180 degrees. And so supplementary angles add to 180 degrees. So we can see that 129 degrees for angle DGE and 51 degrees for angle FGE, those two angles added together equal 180, so these are supplementary. And I can write this as angle DGE is supplementary to angle EGF. Remember, you can name them the other way, EGD or FGE. So these two are supplementary angles. Same thing goes as the complementary. Those two angles, DGE and EGF, they were touching each other, they're adjacent, but they don't have to be. So for angle LMN or NML, that's 63 degrees, and XYZ is 117 degrees. So because 117 and 63 add to 180, they are supplementary angles. Other pairs of angles are called vertical or opposite angles. So when we have two lines that intersect, as in our example here, what it does is forms four angles. And these lines can be intersecting in any which way. So they can look very different on different planes, but they're always going to form four angles when you intersect two lines. So they can be labeled in all sorts of ways. So those are just some other examples. And when we do this, what happens is we get equal angles, and the equal angles are opposite. So they're called non-adjacent because they are not touching each other. So if you look at angle number 1, that is opposite to angle number 3. So they're not touching each other. There's space between them, right? There's angle 2 and angle 4 between them. But these are opposite and equal angles. So angle 1 is equal to angle 3. Even if we don't know what the measurement is of angle 1 or angle 3, we know that they're the same. And that's really key information for us. And those are called vertical angles. So you can think of vertical as meaning opposite. I know that's not really intuitive, but those two words can be used interchangeably. We need to understand what vertical really means in this context. So if angle 1 and 3 are the same, if they're vertical angles, then it stands to reason that angle 2 and 4 are the same. And those are also opposite. So they are vertical angles. So angle 2 is equal to angle 4. So those are vertical angles as well. But it's also really important to note that adjacent angles form 180 degrees. So for example, angle 4 and angle 1, they share a line, right? They're touching each other, but together they make 180 degrees. So angle 1 and 4 are supplementary angles. And so are angles 2 and 3. They make 180 degrees. And also, if you look at it, angle 1 and 2, they form on a line. So they are equal to 180 degrees. And lastly, angles 4 and 3. So any two angles that are touching there are going to also make 180 degrees. And the whole circle, all four of those angles put together, equal 360 degrees. So through these intersecting lines, we can solve for missing angles with the knowledge that we have. That vertical angles, like angle 1 and 3, they're opposite, therefore they're the exact same. And 2 and 4 are vertical angles, so they're the same. And then other angles that are adjacent or touching each other form 180 degrees. So this forms the basis for us to be able to solve without a protractor. The last really cool thing to know is that if you take the corners of any triangle, doesn't matter which way the triangle looks, so we can have triangles that look all different ways. If you cut the three corners of a triangle, you will always get 180 degrees. So if I cut C, A, and B, those corners off with some scissors, and I put them all together, they would form a perfectly straight line, those three angles, which means those three angles together equal 180 degrees. And try it. You can make a triangle, cut the corners out, and form that straight angle. Three angles of a triangle equal 180.